Yes, it's working. So again, when we apply the square root to 9, we do not write the square root of 3. When I apply the square root, which is an operator, this is applied as an operator to 9, it disappears because I applied it. So I can no longer write the square root because the square root is gone. The same thing with the limit operator. So I saw in some of your work limit of 5x plus 2 as x approaches 1 as the limit as x approaches 1 from 7. No. Once you apply the limit, once you replace x by 1, you can no longer write the limit. Okay, so please pay attention to that. When you apply the square root of 9, you no longer write the square root, but you just write the answer. When you apply the limit to this, you don't write the limit of 7 and the limit of 7 and so on and so forth. No, the final answer is 7. So please correct that in your work. What I would do every time I see, every time I get solutions to any of my work, this is what I would do. I will compare line by line, and I put myself a little sticky next to, or just redo the homework, clean in your notebook. I will write a sticky and say, I did not do this correctly. These are the correct steps. Or just redo the whole thing. So you know you are prepared moving forward. Okay, I'm going to share now. Yes, it's a lot of work with all these problems, as you've noticed. Do not, I repeat, do not use the method in the book by multiplying the top by something and the bottom by something. You will lose the absolute value situation, and you will not, most probably, not always, but most probably you will not get the correct answer. So be very careful. So if you want to choose another, we can do another, but I like to go back to this group to choose from here. So it's up to you. What I would do if I were you, I would do all the odd number problems and check the answer. I'm sure you see the same thing. You click on the answer, you see the answer, and ask questions next time. But again, if you feel like working on another problem, I'll be more than happy to look. Maybe we should look at something with E. Yes, I think we should. This is important. I don't want to move on before we look at one with E and also one with natural log. So we have all the spectrum here. Let's do 38. Is that okay with everyone?
Yes.
Okay, so this is e to 3x minus e to negative 3x divided by e to 3x plus e to negative 3x. Okay, I'm going to stop sharing and let's talk about this. So this is a limit. What do we need to do first? Almost always, unless it's an absolute. Yes, very good. Where does this go?
Is that positive infinity?
Excellent. Where does this go?
Negative infinity.
Careful, careful, careful. If the power is negative, the answer is not negative. A to negative n is 1 over a to the nth power. So where does this go and where does this go?
Would that be 0?
Absolutely 0, sure. Because it will be 1 over e to 3x, which will approach 0. Awesome. So where does the numerator go then?
Infinity over infinity.
Excellent. So there is hope. Perfect. Thank you very much. So now I would like to ask, what is the degree? But I can't because these are not polynomials. But in this situation, I see that e to 3x approaches to infinity and e to 3x. So this is the most powerful. I can't talk about polynomials and degree here because they're not polynomials. So this is what I'm going to do. I will factor e to 3x, the most powerful of the two, and e to 3x, the most powerful of the two here. If it were 4x, I would have factored out 4x, e to 4x. But now I have to carefully identify what is left in here. So as Christine asked, so let me stop for a moment. If I have x to the third plus x squared minus 4x, here, if I factor, let's say, the degree, what I do is say 3 minus 3, right? From 3, I subtract 3, so I have to have a term. That must be 1. From 2, I subtract 3, so that is x to negative 1. And from 1 power 1, I subtract 3, and I get this. So that's another option for you if you have any difficulties with this. So this is x cubed, and 1 you have to remember how to write this as 1 over x, and minus how to write this as 4 over x squared. So we're applying the same procedure here, basically. So from 3x, I subtract 3x, or I have to have 1. So obviously, the first term has to be 1. Then minus and plus. So from power negative 3x, I subtract power 3x. So I have e to which power?
Negative 6x?
That's it. And the same thing here, but positive. Perfect. Same idea. So maybe this is better. So now, Christine, do you think that this is somewhat better?
Yeah, that helps me digest it.
Okay.
Would you accept either or?
No. If you write it like this, you will not be able to find the limit. You have to write it like this in order to conclude that this will eventually approach 0 and this will approach 0. You will not know from here.
Oh, okay.
You don't want this. This is just an intermediate step to get here in a roundabout way. No, this is no good. It's good, but you cannot stop there because you are not.
I'm lost how you got positive 6x.
Say it again. I'm sorry. What was I doing?
On your denominator, how'd you get positive 6x?
Oh, yeah. No. Sorry. Of course. From negative 3x up to 3x. I just didn't copy the minus. Sorry. No. My mistake. My apologies. So what will be the next step?
Simplify.
Okay. Where does this go?
0.
Excellent. Where does this go?
0.
Good. What is the limit? And please do not write the limit of 1 because you already applied it. You applied the limit here. So you cannot write this. So the answer is 1, which means y equals 1, horizontal asymptote at infinity. Any questions? Any questions? Okay, let's look at the natural log. Let's choose. Okay, so let's do 41. There are so many different situations. Natural log of 1 plus x squared minus natural log of 1 plus x. Perfect. Okay, I'm just going to stop sharing. Good. Here's the next step. Okay, here's this next problem. So we have a limit and we want to determine this. What do I have to do first? Obviously, where does this go? Anyone?
I still see the computer screen.
Of
I don't
course.
see your-
I'm sorry. Where does this go?
Infinity.
Where does this go? You have to remember the graph of natural log.
Negative infinity.
Okay, we don't remember the graph of natural log then. Here it is. These are extremely important. I cannot say it enough. The graph of natural log is this. That's why we graph them, all of them, so we have them fresh in our memory. Where does this go?
Infinity.
Very good. And the same situation here, by the same concept. Everything is the same. So what is the case that we are looking at?
Infinity minus infinity.
Yep. We cannot conclude. Indeterminate. Good. Well, I have to refresh your memory. I did this a little bit with the properties of logs. Anyone remembers log base A of x minus log base A of y? What does this equal to? Because this is going both ways. This is this, this is this.
That would be log base A of x over y.
Excellent. Perfect. That's what I'm going to do. So I'm going to circle my equal symbol so you know where it jumps now. So limit as x approaches infinity. And can anyone tell us how to write this? Of course, it's natural log. This is for any log, including natural log. From what? 1 plus x squared
Over 1 plus x.
Thank you. Good. So now we already know that this inside is infinity over infinity. What do I factor at the top?
X.
I have to factor the degree. We factor the degree, no matter what it is, and we don't care what I have in the denominator. I cannot apply the cheating method here. I have to factor out the degree. I cannot look at the denominator. So then
X squared.
good.
Parentheses. 1 over x squared plus 1.
Excellent. Who was that?
Caitlin.
Thank you. Good. The denominator. What is the degree?
Which is x.
Good. And in parentheses?
One over x plus 1.
Good. What do we do next?
The x is canceled. Well, actually, you subtract 1.
Just one. Very good. Good. Stay with me. Where does this go?
0.
Excellent. Where does this go?
0.
Good. Where does this go?
One.
Good. Indeed. But where does this go?
Infinity.
Good. How much is infinity times 1?
Infinity.
Good. How much is natural log at infinity?
Infinity.
This is not a number. So this is not a horizontal asymptote. Notice that natural log of infinity is infinity, and the limit is infinity. So that's why at this point I dropped the limit operator because I applied it. I applied it here, I applied it here, I applied it here, and I applied it for the natural log. That's why it disappeared. I cannot write limit of infinity is infinity, so please don't do that, please. Perfect. I think we covered it all, and I'm sure you're going to come up with some other questions that will be fantastic. But you have the idea with polynomials, rational functions, exponentials, and log. Now I would like us to work on one of these problems. Please choose one.
8.
Very good. Give me 1 second to copy it, and then I'll stop sharing. So we have limit as x approaches negative infinity of f of x is negative infinity. Limit of f of x as x approaches 2 from the left is infinity. Limit as x approaches 2 from the right of f of x is negative infinity. Limit as x approaches 2 from either side two from the left, 2 from the right, and 2 from either side is infinity. Really? What? How is it possible the limit from the left to be infinity, the limit from the right of 2 to be negative infinity, and the limit from either side to be infinity? Really? Somebody was not alert when they wrote this problem. Limit as x approaches infinity from f of x equals infinity. I'm just checking, maybe I copied something else. You said 8, right? Negative infinity is negative infinity. 2 from the left, infinity. 2 from the right, negative infinity. 2 from either side. That's not possible. This is wrong. Maybe they wanted a different number here. Anyway, so and limit as x approaches infinity is infinity. Yeah, okay. So what is very important